this video, I will be going through my machine learning research project and discuss its effectiveness in detecting forest fires. Over 18 million hectares were destroyed in the infamous Australian bushfires from 2019 to 2020 alone. Owing to the presence of kindling in the forests, a small fire spreads quickly, destroying all flora and fauna in its path. Countries have utilized various methods to detect these forest fires, ranging from drones, satellites, cameras to manned fire towers. Croatia, a small country constantly affected by these forest fires, are now setting up video surveillance networks to detect these forest fires before they become uncontrollable. So, I propose to employ image classification algorithm through transfer learning to detect these forest fires, eliminating the need to review the footage manually, thereby saving critical time. Now let's discuss the project in detail.
The system uses the MobileNet image classification model designed on Edge Impulse and deployed on the TinyML kit. As you can see, this kit contains a camera and an Arduino Nano 33 attached to the shield. The camera captures a picture every 2 seconds, resizes it to 96 by 96 size and sends to the ML model. The classification output from the ML model is averaged for every 10 readings and used to switch the red LED if fire is detected. I have used a 3D printed tower design for the enclosure with a dragon sitting on top to symbolize the fire. Now let's talk about the design of the model. For the model data, I was able to download an initial batch of label data from Kaggle that labels for fire and not fire. To balance this dataset, I downloaded an additional batch of data from images.cv to add to the not fire dataset. In the next step, I used the smallest MobileNet model version 1.0 to design the ML model. The model accuracy was quite good at 93%. However, the rate of false negatives was very high at 15.7%, which meant that a lot of fires could go undetected. I tried to use heavier versions of MobileNet unsuccessfully because any model over 100 KB was found to be too big to run on the Arduino Nano and resulted in errors. In the end, I added an additional dense layer of 8 neurons along with data augmentation and data balancing to the initial model. This provided a much better result at 97.2% accuracy and a very small false negative rate of 4.9% during validation. It's time to deploy the model on the TinyML kit. The model created in the last step on Edge Impulse, which is of 62 KB, is small enough to run on the setup. The new library includes a sample Arduino sketch for object detection, which is compatible with the TinyML kit. After installing other libraries, I modified the sketch to handle the output inference to switch on and off the LEDs based on the output. I also added an averaging method to stabilize the output. To test the performance of the ML model, I performed a test run on Edge Impulse to classify unseen pictures from the collected dataset. The rate of accuracy was good at 96.54%. After deploying the model on the Arduino Nano, I used images in front of the camera as input because it's not possible to simulate forest fire scenario. There were some observations during the testing process. It was required to point the camera directly to the fire scene in order to classify it. In a real-world scenario, we would need a PTZ camera to capture pictures from every angle to be able to recognize it. Also, it was observed that every time the setup started, the first few readings would often be misclassified as fire. And when the exposure level in the environment suddenly changed, the model also misclassified the environment as fire. Possibly because the model was trained on forest images and not indoor images. That would also explain why the indoor lights are often misclassified as fire. So are objects with reddish color. This might also result in faulty readings in autumn when the leaves change color. Also, small lights like lighter fires, which are fires of white color, are not recognized by the model. In the end, I would conclude by saying that in spite of some limitations, the model is found to perform well at detecting forest fires from initial tests. However, a further round of tests in a real forest could be done to confirm the results.
Please watch my GitHub project with the link given below for more details. Thank you.